Greetings. As we get started today on some rules for logarithms and about different properties of logs, on these different properties of logs, we will be using some things that you have on your reference page. This is all the way at the front of your packet. This page that looks like this, it says Algebra 2 reference sheet. And down here at the bottom, you see that exponential equations. That's going to come in handy with the information written down there as far as when we start writing, doing our applications. Also converting to and from log form to exponential form. And then at the bottom, these three properties, the product property, the quotient property, and the power property, those are what we're going to be talking about next. And you also see your change of base that we just talked about in the last lesson. So just heads up, if you haven't got that handy, you might want to have that handy. It'd be a nice place to just know that you already have those notes kind of in one place. It is in the notes we're getting ready to take, but you also have this on the reference page. If you use the factor sheet, it's on the back of the factor sheet. All right, so from there, if you will switch back into your specifically Unit 5 packet, and this is on page 9. And this topic is properties of logs. And remembering that logs and exponential, remember logs and exponentials, there's a relationship there, then it should help you know why these log properties work the way they do. So the product property, then this works when the bases are the same, kind of like some of those exponent rules, right? So remember with exponents that if I had x to the 5th times x to the 3rd, what did we do with those exponents? The problem is a multiplication problem, but we actually add the exponents. So log base b of these two things multiplied times each other is the same as if I add their logs individually. So the fact that there's a b there, that just means the base, whatever base, and illustrating that it has to be the same. So multiply goes with add, just like it went with add in our exponent rules. So we talk about condensing and expanding. So remember that condensing means we're making it smaller, and expanding means we would be making it larger. So we're going to use this rule going in both directions. And again, you can look back at what you have on the reference page because it shows them side by side. So here I confirm that my bases are the same. So if I want to write this with one logarithm, base still stays the same. And then I would be doing 7 times 4, which of course 7 times 4 then would be just 28. So instead of writing that, I could just write log base 2 of 28. Now sometimes they're not going to be whole numbers. Sometimes they're going to have variables, not just numbers, not constants. And so that's why we need to know what the rule is, because we won't always just be able to do that. So here, this would be log, right? These are both common logs, and then 4 times 25 is 100. And now this actually says simplify if possible. So if I have log base 10 of 100, so then what is, that answer is just an easy 2. Because 10 to the second power is 100, right? So typically you're not going to see this simplify if possible. It's just going to, your exercises are just going to be asking you to condense or expand. So in number 3, again, if I'm condensing this, then that's going to be log base 4. And then these things are going to get multiplied together. 2x times 4x squared. So then that becomes log base 4 of 8x to the 3rd power. And then oftentimes you'll still see that in parentheses. The parentheses there are to make sure that we know we're taking the log of that entire thing, not the log of 8 and then multiplying times x to the 3rd. So if we're going to expand, then we need 2 things that multiply to be 6. So for instance, this would be the same as saying log of 3 plus log of 2. So expand, we're going to get bigger. And typically what we're going to see is something more like number 6. These that we've been given on 4 and 5, there's actually more than one possible answer. So here I could do log base 7 of 3 plus log base 7 of 15. Someone else might write down log base 7 of 9 plus log base 7 of 5, because 9 times 5 would also give me 45. They would still be equal. So in number 6, though, it's just a 5 and an x, so this one has only one possible answer. I mean, I suppose you could switch the order. So 5x is the same as 5 times x, so remember that multiplication goes with addition. So that's the same as log base 2 of 5 plus log base 2 of x. So that's our product property. So remember, multiplication goes with addition. And so then it may seem familiar to you, and it may seem reasonable then, that the quotient property, which quotient means division, right? And if multiplication goes with addition, quotient goes with subtraction. And also if you look at 7, 8, and 9, you see a bunch of subtractions. And just as a reminder of the connection to exponents, if I had x to the 5th over x to the 2nd, I would subtract to get x to the 3rd. All right, so a little connection that you already know, division goes with subtraction. So then if I was to rewrite this, this would be the same as log base b of m subtract log base b of n. The one on the bottom needs to be the one after the subtraction sign. So here, this is log base 3 of 24 over 8, which is also, by the way, the same thing as just log base 3 of 3. And anytime those two numbers are the same, that whole thing could just be simplified to have no log and just be equal to 1. So here, log base 2 of 15 divided by 15. So that's the same as log base 2 of 1. And if I'm to simplify that, 2 to what power would equal 1? This whole thing just equals 0 if I were to actually be able to simplify it. So these first two can be simplified. I will not typically be giving you questions and ask you to condense and simplify in the same question. I would more want to know, for instance, like number 9 maybe. So here I have log base 4. First one's on top. So I've got x to the 9th over x to the 2nd. And then if I can do something with that division, I should. Now if they were different variables, I couldn't, but here I can. So this would be log base 4 of x to the 7th. And then that doesn't simplify in any way to be able to get rid of the log because we still have an x. So condensing, our answers are going to look much smaller than they started. Expanding, our answers are going to get longer. And in this one, I personally don't care for this problem much, but 4 is like, you have to think of it as being the answer to division. So you've got to come up with something that would divide to be 4. So I could say, let's say log base 8 of 20 minus log base 8 of 5, because 20 divided by 5 would be 4. There is an infinite number of things you could put there. So I could get lots of things that would turn into 1/3, but the easiest thing here to do would just be, say, log base 5 of 1 minus log base 5 of 3. So the top first, the bottom second, and they both have their own log. So here, log of m, common log of m, minus common log of 7. And that is the quotient property. Division goes with subtraction. So just get mad about it. Get your mads on. Multiplication goes with addition. Division goes with subtraction. Maybe that would help you remember which one goes with which. Hopefully, if you know your exponent rules, that's not a hard transfer. So last we're going to look at here is the power property. So we're still on that same page. This is the power property. And log base b of m to the n power is the same as n times log base b of m. I think of it as the exponent jumps out front. Right? So like the exponent jumps out to the front. So when it's condensed, there is not a number out in the front. All right. So, and if you think about this, that power, the power goes with multiply. Remember with exponents, something like 3 to the 2nd to the 4th power is the same as 3 to the 8th. So if I am simplifying this, then I'm putting the power back on if I'm condensing. So this would be log base 4. The 5 jumps on as the exponent on that argument, which is the 2. And then simplify that if you can. So 2 to the 5th power is 32. And then we're not going to worry about the simplified part at this point. We're just going to leave that there. So the 7 jumps on the x. And you may think, like, I'm not going to remember which one is condensed and which one is expand. Well, typically what's going to happen is if there's a number out in the front, then it needs to be moved and added on, or vice versa. So here the 1/3 is going to go on the 8, so log of 8 to the 1/3, and then I should go, if that's a number raised to a power, I should go ahead and do that. So if I use my calculator, I find out that 8 to the 1/3 is 2. So that's just log of 2. So when we're expanding, we're taking the exponents off. The exponents are moving to the front. So the 7 moves to the front. And that would be the expanding part. Now, I could also do more with this to evaluate it and simplify, but right now we're just going to worry about the expanding part. So this x to the 1 would jump out front, and it would actually get multiplied with what's already there. And we would have to distribute. So a little tricky there. So this would be 3x minus 3 times the log of 4. And this may not look like it has an exponent, but remember from when we did radicals that a radical, the square root sign, is the same as a 1/2 as an exponent. So something from Unit 4 popped up here. The 1/2 would jump out front. And we still have, notice that the base isn't changing. All right. Okay, so let's take a look and see what your assignment is going to look like in IXL. All right, scratch that. We'll go ahead and do a little bit of what's on your next page here. I believe this is page 10. And so here, make sure that you take care of the power first. So we're putting more than one thing together in the same problem. So the 2 is a power that's going to jump on the 6. It goes on what's right after it, not the very end. So this would be the same as log of 6 squared minus log of 9. And if we're condensing, our final answer can only have the word log one time. And then subtraction goes with division. So this is the same as log of 36, which is 6 squared, divided by 9, which is the same as common log of 4 as our final answer. So let's move down here to 21. So the 7, he's the exponent that's going to jump on the u. The 3 is going to go over here with that, be combined with that exponent. So I'm going to go ahead and do that part first. So I have log base 4 of u to the 7th minus log base 4 of v to the 2 times the 3 would be v to the 6th. And then I need to condense that. And you may feel comfortable doing both those steps at once. That's perfectly fine. U to the 7th over V to the 6th. So you may feel comfortable, or you may get comfortable doing both those things at the same time, but they do both need to happen. So let's look there at 22, where we have some numbers and we actually have a plus and a minus. So remember that plus goes with times. So when I put these two together, the first two together, I'm doing log base 2 of 15 times 4, right? And then we're going to be dividing that by the 6 because of this minus. So those first two were multiplied, and then we're dividing. So 15 times 4 is 60, and then 60 divided by 6. Notice that our answer is not just a 10. Log base 2 of 10. So those are some examples that are condensing, so they're getting smaller. All right, so we are ready to do some expanding. So we have log base 6, and when you're expanding, every variable, if you have multiple variables, they're all going to end up with their own log. And if there was a constant, it would also end up with its own log. So I'm going to have log base 6 of the x. These are being multiplied, so this is going to be addition, plus log base 6 of the y, plus log base 6 for the z to the fourth, and then the z to the fourth, the 4 is going to come out front. The other parts stay the same. So you might very much prefer to just do that at the same time. But kind of to show you what's going on. So they each got their own log, and any exponents comes to the front of that individual log. Now, something like 29, personally, I would get rid of that outside exponent first. I would go ahead and make this q to the 8th, r to the 4th, and then work with that. So then we would have log base 7 of q to the 8th plus log base 7 of r to the 4th, and then exponents out front. Or you might just think of those exponents coming out front when you first write it down. So here in 30, I'm going to get rid of that outside one first personally. So multiplying those using my power property makes that a 2 and a 10. And now this time I know it's division, so I know there's going to be a minus in the middle. So I have log base 2 of y to the 2nd. So I'm going to go ahead and put y. And then instead of writing my second, I'm going to write it in the front. There we go. Minus log base 2 of z. And then I need a 10 in the front of that, which I did not allow enough room for. It's a poor time for my stylus to not work, but minus 10 log 2 of z. So the exponents come immediately before that log. Division changes to subtraction. All right, so let's go ahead and jump over to see then what, again, as I said we were going to do before, what we get in the assignment. And you could use some of this space. You could just scratch out some of these problems. Some of these are a little hairier than what you might see. They're definitely hairier than what you're going to see on your test. All right, I know, another delay on looking at IXL, but the next page in your notes, sorry, I lose track of what I've given you in the notes. The next page of your notes is kind of another one-stop shop to demonstrate some of these rules. And some of these things that we've already talked about a little bit, I've talked about at least, hopefully you've thought about or you've noticed. And so this is going to help you as we go through these next IXL lessons. Again, besides that, also you have it on your reference page, but I think you'll find this is helpful for the lessons 8, S8 through S12 that we'll take a look at in a minute. So let's fill these out to give some examples. So if you see that the base, these two numbers are the same, right? The base and the argument are the same. We know that that's always going to be equal to 1. If I see, no matter what the base is, if the argument is a 1, we know it's equal to 0 because we know anything to the 0 power is 1. So for instance, when you see the examples at the right, those both being 14s, I should be able to recognize immediately that that's a 1. Log base 3, the argument is a 1, so I know immediately 3 to the 0 power. Anything to the 0 power would give me the 1. And then some of these are the rules we just talked about, just a place to rewrite them. By the way, there's nothing really magical about using M and N, and so you may have one place in your notes it uses a different variable, still the same thing, so that when we're condensing and expanding, addition goes with multiplication. So 6 times 7, this would be 42. And if I'm going to expand this, again, any way that would multiply to be 63. So more than one right answer. So log base 2 of 9 plus log base 2 of 7, or 3 and 21, or 1 and 63, etc. Quotient rule, remember that is division. So this would be that log base b of m minus log base b of n. And so to condense, I would be writing this in a fraction. So this would be 84 divided by 12, which would be 7. And this would be, I could write this in any number of ways, like 18 over 2, which would then become log base, or common log of 18 minus the common log of 2. Again, this example and this example, because they are just numbers, there are more than one answer that would work there. Typically, we're going to see something like x and y, and then we would have x times y. All right, so power rule. This is where our exponent comes in, because the exponent represents a power, and it's the same as n times the log base b of m. So if I'm condensing, I'm putting the exponent back on. So this would be the same as log base 3 of 8 to the second, which is log base 3 of 64. And then here, the x minus 1 would come out front. Would need to stick it in some parentheses to show that the whole thing is being multiplied. And most of the time we don't have, it's more like just a number there. And then change of base, we used y and b before. Doesn't matter. It's still, that number is on top. This is on the bottom. So an example here, we would be doing log of 32 over log of 7. And if I'm actually going to evaluate it, then I would use my calculator to do log 32, close the parenthesis, divided by log 7. And I got 1.781 if I'm going to the nearest thousandth. And so those notes are going to be helpful as we look at S8 specifically, just to ask you to classify. So it may be helpful to see some examples in one place. All right, at long last, here is IXL examples. So this is S8. All right, this is S8 on IXL. And which property have they used to make those changes, to show that those things are equal? What do I see that's different? I see the exponent move to the front. And hopefully you recognize that as being the power property. So again, exponent has moved to the front, right? So power property again. So subtraction has been condensed and written in a fraction, which is quotient. Subtraction written in a fraction, again, quotient. addition, and then 7 times 5 is 35. That is product. So let's see if we jump a level, if things get harder. Don't foresee so far. So when you talk about this are well defined, just because the U, they're saying like U can't be 0. So this would be quotient. Don't be thrown off by all the extra words up there. So this time, addition goes with product because it goes with multiplication in our rules. So same kind of thing here. Subtraction goes with division, so that's quotient. What's happened here? Our exponent moved again, so this would be power. So this one is a little different, right? It's a little different. We might expect that 2, why isn't that come out to the front, right? But 2 log, like if I have W times WX, so this is actually product. So think the addition has changed into a multiplication. That is still product. Still just move that exponent. Still just move the exponent. So if the exponent has moved, yeah, except for that one that had addition, I guess. Still just move the exponent, all right? So in my case, I did not get any that were change of base. Notice here, now that's change of base, right? The base is no longer the same. But for me, that didn't happen until 83. All right, so S8 should be quick and easy, especially if you have some examples that you've taken your notes. It should not be something that you're randomly guessing and it takes 500 questions. And then S9 is specifically about product property. And so if I am to expand, then I know I need log Z, and this is product, so it's going to change, it's going to be addition in the middle, and then log with the Y. So this would be log 11 plus log Z. Let's jump ahead and see what else we've got here. So here we're going to a single logarithm, so that's the same thing as condensing because we're going down to a single. So addition goes with multiplication. So 8 times 2 makes that 16. Same kind of thing, 3 times 5, this would be log of 15. Now we're expanding. So log 7 plus log t. So you're either making it into more than 1 or you're multiplying to make it down to 1 to condense it to a single, because this is all product property. So here I have to actually put in the base. So I have 7, and then 4 times 2 is 8. So log base 6, and then 9 times 6 is 54. So expand, so log 7 the 2 gets his own log, plus, and they both are going to have the same base. You can't like mix it up and use one common log and one base 7. All right, so hopefully that does not seem like anything extreme. That was all product property, so you get a good chance to practice only multiplying. So you'll either be multiplying them or putting a plus in the middle. And then in 10, now we're going to go with quotient. So remember a quotient, when I'm expanding, it's going to be a minus in the middle. So common log of 17. Make sure your minus is outside of those parentheses. Common log of u. See if we can get something a little bit different. So same thing here. Now if I'm rewriting it into a single, I know it now, it's going back the other way. I need the fraction. Log of 3, log 7 on the bottom. Oh, let's see, what should I have done? Oh, I should have finished it and made it only one log. So single logarithm means only write it once. Not exactly sure what I was thinking there. They give me a whole bunch of other information. It does mean that, but I only want to write it with one log. Gotcha. So let's try that again, Miss Carolyn. And then, so the fraction, the argument is what is in the fraction, not the whole log in the fraction. There we go. All right. And I won't be re-recording to cover that up because I already have 30 minutes here. 8 over 9. All right, so single log. Now, if the 4 over 9 would reduce or something, then you should simplify that. So that's what that's about. This would be a minus in the middle, log t minus log u. Let's see if we can get something a little different. So this one, we just have to make sure we use the base. So I'm going to have log base y of x, and then outside the parentheses, minus log base y of z. So if the fraction, like this is going to be 3 over 7, if that was 63 over 7, you should divide it to get 9. That's what this whole simplify the fractions means. Right, so hopefully we've learned from my mistake. Single log means only type log once. Duh. All right, so let's see what S11. So several S's here, but they should go very quickly. Should be some easy points. Next one is power property. Remember that has to do with our exponents. So that exponent is going to come to the front. So 2, and then log. I don't need the one with the base because there's no base here. It's just common log, and then the u. So 6, my exponent comes out front, log, and then the z. So hopefully, again, those are going to come out pretty easily. Let's see what happens when we jump a level. Just happen to have one here with a base. So pay attention for bases when they change from being common logs. Base is staying the same. The 3 came out front, and then my y. Goes back to just the common log. That base could be a variable instead. So 4 log base u and then T. And I don't think it's going to get harder then until you're in the 80s. So you should be good there. And then S12, you actually have to pay a little more attention because it's a mixed review. It's the same things you've just been doing, or we've just done together, but it's mixed up, so you might be using a different, so you're going to have to keep in mind which thing you're using each time. So here I'm supposed to expand, so the 13 and the W each will get their own. Log, it's still base 5, so log base 5 of 13, go outside, and then minus, and then log base 5 again of the W. So these are just going to be mixed up. So you might have a few that are quotient rule, and then you might get, so now we have a product rule. All right, so the same things we've been doing, just all in one lesson. So again, this one would be quotient rule. You would rewrite it with subtraction in the middle. All right, so those are our properties of logs. Let's look at this one just to make sure nothing crazy going on here. So log base 9 of 17 plus log base 9 of E. E is a special, it goes with natural log, and so I just want to make sure that they're not going to change things up here. Nope, still the same thing. So if you just treat it like another variable, you're all right. So now we have that ln, natural log. It's just another way, it's kind of like common log. We still need to put the 5 on the 2. So we're going to say natural log instead of log. And then 2 to the 5th power is 32. So what I did here, the ln, or natural log, that's what that stands for, natural log, just behaves like the log, but I need to put the 5 on the 2 as an exponent, and then 2 to the 5th power was 32. So that's how I got that answer. And it was A-OK. All right, so don't let that throw you off. This one's going to be very similar. Log base 3, again, 2 to the 5th power, so I'm using that 32 again. So if you put a power on an actual number, on a constant, you will be raising it to that power. So this one has 2 steps, so more like some of the harder ones in our notes. So the 4 is going to go on the 2 as an exponent, right? So 2 to the 4th power makes that 16. And then I'm going to be doing 6 times 16 because I'm supposed to put this in a single. So this would be log base 9, the base isn't changing, and then 6 times 16, this is going to be 96. So log base 9, and then I'm doing 6 times 2 to the 4th power, which is 16. 6 times 16 is 96. So that one actually had a couple, so we may have things that involve more than one of the rules, which is good practice because on your test there's going to be some things with more than one of the rules in the same problem. So here, this first part is divided and then multiplied. So we have in 1, so I'm going to have 14 minus the 8, and then times the 4. The 8 is the only one in the denominator, so the 14, you could do 14 times 4. That might be the simplest thing to think of that. 14 times 4 is 56. 56 divided by 8 is 7. And that's where that whole business of simplifying the fractions comes in. That we would not, it's going to be when it's numbers. So log base u of 7. Log base u of 7. Notice that is not the same thing I would get if I actually add and subtract. And that takes me up to 81. All right, hopefully that was helpful. That is the one video for the entire day. So I know it's kind of long, but one and done.